Hi, this is Nadina, your trash pirate, and today I'm going to talk about Avalanche, which is a chain I personally really like. So I would like to give you an overview what this project is all about, because most people that just know the coins associated with the AVAX, but they actually don't know why does this chain exist, what kind of problems does it solve, and how do they solve the problems. So I want to spend some time to give an overview how Avalanche differentiates itself from Ethereum in particular, because it's an EVM compatible chain. So you can take any smart contract you develop on Ethereum and you can pretty much just deploy it on Avalanche. There's some edge cases you need to be aware of, but in most cases, you can just deploy any Solidity smart contract on Avalanche without any changes. So yeah, how does Avalanche set themselves apart in the plethora of blockchains out there? And why should you care about it? So Avalanche is an L1, and as I mentioned, it's EVM compatible, but has some unique features. So when you go to the documentation, here you can look at the architecture and explains really well how Avalanche is unique. And so here you see that Avalanche primary network, which most people interact with, consists of 3 blockchains. So also in Ethereum, we have 2 blockchains. We have a consensus layer and we have an execution layer, but here in Avalanche, we have 3. The first is the platform chain, which is basically responsible to manage the validation chain, the seed chain, which is the chain that probably most people interact with, since smart contracts live on there, ERC20 tokens and such. They're all deployed in the seed chain. And there is also an X chain, the exchange chain, which is, as far as I understand it, very similar to the optimized BNB chain, which is just an kind of an asset chain. So the native token lives on there, but anyone can deploy native tokens on the X chain. So it's kind of optimized for transfer to have really quick settlements. But what now is very unique about Avalanche is that you can also deploy subnets. So anyone can create an L1 themselves, a so-called subnet, and they're all natively interoperable. So it's very easy to transact between the different subnets, and also the validators that validate a subnet, they can validate any other chain as well. They can kind of opt in and out as they want to secure the primary network, but also subnets that are out there. And these subnets are they're isolated, so you can have very application-specific subnets. And then you have a lot of options how you configure these subnets in terms of the consensus, the native token, or like the gas fee token, compliance regulations. For example, you could enforce KYC for each validator if that is required. You can make sure that interacting with your subnet is compliant with the jurisdictions you're in. And that's very much like the vision of the founder of AVAX. With him, and it was very interesting because he was basically saying the idea that blockchains can kind of live outside of the regulatory landscape is kind of utopian. There will always be cases where blockchains have to comply with certain regulations, but regulations differ around the globe, and it's very hard to make one network compliant with everything, with the entire, with all nations essentially, or all jurisdictions. So this type of modular setup allows to make certain subnets compliant with certain jurisdictions and makes it much more adaptable because you can configure it however you want. So flexibility in how you set up the chain allows a business, for example, to have only permission validators, which might be very important for like a business. They don't want anyone to validate. Or if you do some business or just I don't know, you work with financial institutions, you might need KYC for each validator. So you can set it up like that. So there's a lot of different use cases for a subnet, from making it super cheap for a gaming application to very business specialized subnet. So that's what I think is very, compared to other blockchains out there, it's very business oriented, because there you can like get adoption in so many different areas, and you really have, like, as they call it, blockchain as a service. So very cool feature of Avalanche. So what's also unique about Avalanche is its consensus algorithm. And maybe you need to know a little bit more about the Ethereum consensus algorithm to really understand how it is different. And I recommend to watch actually this video here by Block Native, Anatomy of a Slot. It's very informative if you want to learn more about how consensus is reached on Ethereum. But I'm just going to talk about briefly about how transactions are finalized or confirmed on Ethereum to then compare it to Avalanche. So on the consensus layer in Ethereum, everything is processed in slots and epochs. So a slot is 12 seconds and includes basically, or can include a block. It's not required, but you have one block or less. And an epoch is 32 slots. So in each slot, you have validators voting or attesting to the validity of a block. And after 32 blocks, which is equivalent to 6.5 minutes roughly, and 2/3 of the chosen validators agree on the validity of the block, you call it justified. And after another epoch, and still 2/3 of the validators agree on it, you call it finalized. So if this is the latest block here in pink, then the block on slot 32, that is a finalized block. And so what this basically means, and that's a very high level, and there is a lot more to it, but this basically means that 2/3 of the validators, or you also should say 2/3 of the stake. So it's weighted by the stake of each validator, obviously. 2/3 have to attest to it and agree on the block. And it takes almost like 13 minutes to get a transaction finalized and considered as not changeable anymore. Some applications are happy with the justified state, but officially finalized and unchangeable is when the transaction or the block is finalized. But that's a long time for certain applications, especially when you think about gaming, where things happen really fast. You don't want like. So how did Avalanche address this? An Avalanche is very unique consensus algorithm to speed this process up and make it more scalable. So they have a really nice example that I'm showing in a second. But basically the key component to it is that not all the validators have to agree, or you don't have like a majority threshold of all validators that need to agree, and then you can go on. It's based on a so-called gossip protocol where you're subsampling and you're doing rounds of subsampling on validators to get confidence into the transaction is valid. And that is more of probabilistic approach. On Ethereum, you have basically deterministic, so you're certain that it's actually valid, while on Avalanche, to gain more speed, it's very likely that their block is valid. So they have really nice demonstration here. So let me reset this. So this is essentially how it works. So each of these squares is, you can think of as a validator that has an opinion whether a block is valid or not, or whether it's faulty or not. And and how the protocol works is that each of these validators is randomly sampling, in this case, K means 10 other validators, to see what their answer is. They're asking, is this block valid or is it not? And it takes on the decision that was made by the majority of the validators it asks. So if it asked, it asks 10 validators, is this transaction valid? If 8 of it, this is the alpha here, if 8 of it say yes, it's taking on that the block is valid. And this demonstration is basically, you can see that it will over time just basically collapse into one of the two colors. And even if you mess around with it, it will still do that. So if you run it, and I can try to make these a different color, it still collapses to one color, which means they come to an agreement, which is the whole point of the consensus algorithm. So I'm not sure if I explained this very well, but when you go here to the documentation on the Avalanche consensus, down here is a really great video where it explains how this all works. But yeah, given that you can subsample and you only need a few rounds of voting, this allows not only to get to a decision very quickly, and you're finalizing within less than a second, but you also, when you scale the network and you have more and more nodes, it actually doesn't, the time or the computational load to vote does not scale with it. It's always, let's say, if always 20, I think that 20 is roughly the number that they have currently in the network. So if only a subsample is always 20 validators, that remains the same regardless how large your network is, which allows it to scale very easily and with the same security, which might not be the case with Ethereum. And so that's why I really love this blockchain, because it actually seems to promise quite scalability and security and speed, which you rarely have all the time, rarely have altogether. So I'm very excited about Avalanche. I think it's a great chain. Also, what I mentioned with these L1s, so they have to create subnets, and it's in beta and it's not complete because certain options you still don't have, so you would have to do that programmatically. But basically you can just do a walkthrough here. All you need is a core wallet, and I believe it requires 2000 AVAX to spin up a node. But yeah, basically you just can click through the prompts and launch your own blockchain with your own configuration, your own gas token and whatsoever. So I think this is really very promising and very interesting to businesses. And as they say, blockchain as a service, it becomes this easy, and you can configure it and tweak it however you want. I think that's very cool. And also, what I wanted to mention, for Avalanche really has put a lot of effort into onboarding gaming. So if you haven't, I haven't, I actually still need to check out the newly released game Off the Grid, which is very similar to Call of Duty, which is supposed to have very good graphics, very good performance, and is, I think, one of the first, or one of the few, if not first, really big tier one games that are blockchain powered. So I highly recommend to check it out. So yeah, this was my overview on Avalanche. I hope it gave you some insight on how Avalanche sets themselves apart from other blockchains. I'm very bullish on it, I would say, as I see how everything is very thought through, and yeah, I'm curious how to see where they're going. I think it's very promising chain. So thanks for watching. If you like this video, give me a like, share it around, please. And yeah, I'll see you at the